Hey guys, welcome back. I thought I'd do a quick video again really quickly because today at my school I had a student come up to me at lunchtime and ask me how to work a problem about completing the square. So let's actually go over completing the square. Now this is for quadratic type problems, basically polynomials that have like x squared minus 5x plus 3 in it or something. So let's actually look at one of these. Alright, let's make one up so we can work it. We've got x squared plus, let's use the 5x like I said, plus 5x minus, say 11. And they want us to complete the square, so solve by completing the square. Well, the first thing that we need to do in order to solve this f of x problem that you see here, or this y equals problem. So if you need to envision seeing a y equals here, I'll write it there for you. But what we're going to do is, instead of wanting to write this y equals or write f of x equals, or even if it has a y equals or an f of x equals, we want to just ignore that and set this thing equal to 0. Now before you can begin completing the square, what you want to do is you want to isolate anything that has an x with it. So really your first two x terms, the x squared and the plus or minus whatever number's in front of this regular x. You want to get it on one side of the equation. So basically what you have is you'd have like x squared plus 5x, and leave yourself some space, equals 11. Now what you just witnessed is me moving the 11 over here by adding 11 to both sides. So plus 11 gives me 11 here, and the 11 and the negative 11 would cancel out. Now what I need to do is get ready to complete the square. Now what I like to tell students to do is open up a big set of parentheses, and this really large set of parentheses is what you're going to be completing. It's going to be the square that you're going to complete. So there's the square symbol, and what you will do is you will write this letter x. Now one simple rule about this: what you basically need to make sure is that there is not a number in front of the x squared. If there is, in the very beginning of the problem, you need to divide everything in the problem by that number that's in front of the x squared. Okay, so we have x. Now if you look, we still really have x squared here, because there's x and being squared, so we still really have it. But you're going to create a new number. The new number that you're going to create is going to be plus 5 halves. So you will always take half of the number that's always in front of the regular x. Okay, so if this would have been a negative 5, we would have wrote negative 5 halves, here. Okay, and if it would have been, say, minus 7, you would have wrote minus 7 halves. You will always take half of that number. Now, you just got through creating a new number. So what you will need to do is you will need to account for this creation that you just did by adding it to the other side. So basically, whatever that sign is, make sure you write it down with that number. You know, pluses technically do not matter, but I would strongly recommend it because you need to get used to it when you square things. But anyway, we end up getting this. Surely isn't as nice looking as before, but we're trying to solve this without using the quadratic equation. So this gives us x plus 5 halves, quantity squared, equals 11 plus, now we need to square this positive 5 halves. 5 squared is 25, 2 squared is 4, so that would give us 25 over 4, because 5 times 5 is 25 and 2 times 2 is 4. Now we need to do some basic math. If you need review on adding fractions and things like that, you can go to Khan Academy, which is free to anyone. But anyway, this will give us x plus 5 halves, quantity squared, equals basically 44 over 4. Now you're probably wondering, why in the world is he writing 44 over 4? Well, what is 44 divided by 4? It's 11. Now why did I take the time out to do this here? Well, notice that this denominator here is a 4. In order for me to be able to add two numbers together, they need to have a common denominator. This 11 here has a denominator of 1. So I multiply the numerator, which is the 11, and the one that's below the 11 by 4. So 4 times 11 is 44 over 4 because of the 4 times 1. Anyway, that would be 44 plus 25 over 4. Now we need to add this together. And it looks like I'm almost running out of real estate here, but I'll move down. So now I'm going to add these two fractions together, and that would give me, well, I still have this x plus 5 halves, quantity squared, equals, well, what is 44 plus 25? Well, that looks like 69 to me, because 4 plus 2 is 6, and 4 plus 5 is 9. Whew, that was close. 5 plus 4 is 9, 2 plus 4 is 6. It's 69 over 4. Now, I need to solve this for x, so what I will have to do now is I will have to take the square root of both sides. And I'm doing that so I can get rid of that square. Now in doing so, that gives me x plus 5 halves. Now the square is gone. And like I said, the square root symbol that you see here cancels out the square symbol. And that leaves me with x plus 5 equals, now the square root of 69, well, it contains a 3. And that would be 23. 23 is a prime, and 3 is a prime, so it's not going to be simplified. So I still have the square root of 69 running around here. But the square root of 4 is 2. Now, I don't know if you've noticed, but I'm not actually done with this part. I'm supposed to have plus or minus here. Now, this plus or minus should be here because in the original problem, if you remember, it was a square. That means that there's two solutions. So I have to show all the possibilities of these solutions. Okay, so I have to have plus and minus here showing the two answers. But anyway, my final answer will be x equals, and I'm going to subtract 5 halves from both places. So I'm picking up the 5 halves from here and moving it over by changing its sign, so that will be a negative 5 halves plus or minus the square root of 69 over 2. So this is my answer. Now I've got two of them, and if you don't see both of them, I'll rewrite them. That way you can see both of them. Didn't mean to make that so big, but I'll try to rewrite both of them for you. I'm a little lazy, so I'll just post them over here. That way you can see them. There's this one, and I'm going to post it again, and here's this one. And if you look at it, you're like, hey, it's the same thing. Well, let me clean it up a little bit. That way you can see the differences. Alright, anyway, one of them is a plus, and the other one is a minus. So, whoops, I marked out the wrong one. One of them is a plus and one of them's a minus. And that way you get both of your answers. And here's the two answers that I got by completing the square by hand. And if you need to check these, you can check them with your TI-83 calculator. And the one that I have programs in mind. Yes, I know programs. I know a lot of math teachers don't like students having programs and everything, but man, I love programs. So, but anyway, you can check them. Like I said, if you want to check out that programs, for the TI-83 calculator. I've got them on my website. Well, I'll put a bunch of calculators. I've got them on my website. You can download those programs and load them onto your TI-83. But anyway, let's go ahead and check this. Make sure I've worked it out by hands correctly. Quadratic program. Let's go back up here and look and see the original problem. The number in front of the x squared is a 1, so I type in 1, press enter. The other number's a 5, type in 5, press enter. The other number's a negative 11, type in negative 11 and press enter. And we get negative 5 halves. See the negative 5 halves plus the square root of 69 over 2. Okay, all they've done there is they've written it with one denominator. Okay, and I've written it with two separate ones. I'm so used to doing that because of complex numbers, imaginary numbers. You have to get them in the form of a plus or minus bi. So anyway, I hope this was helpful. Those of you that were looking for a tutorial video on completing the square, so just watch it, and I hope it was helpful. Alright guys.